definitions of functions and there are several objectives. We're only doing find the domain of a function today, and then we'll do the others tomorrow. So, finding the function's domain. If I have some function, let's just say y equals x squared plus 3x minus 4. The domain of any function that I give you is the set of real numbers. We're only plugging in real numbers. There are some exclusions. You cannot exclude from a function's domain real numbers that cause division by 0. So we did that in 1010. If you have something like this, you can't just pick any number you want because you have a rational expression there, rational function, and you have to worry about what would make that 0. So in this case, what would make this 0? 3. So you'd say it's all real numbers except for x cannot equal 3. Here, is there anything that's going to make it 0 in the denominator? There is no denominator, right? There is another thing that you have to worry about too, and if you plug in an x, that will give you, it says here, cause division by 0 and real numbers that result in an even root. So if you're taking the even root of a number like the square root or the fourth root, and that x gives you an imaginary number. You can't pick an x that's going to end up, after you plug it in and simplify, you get imaginary numbers. So those are the two restrictions you have to worry about. Let's just review really quick how you would write this in interval notation. So here I'm saying it's all real numbers except for x cannot equal 3. Can you guys remember how I'd write that domain in an interval notation? You got everything except for you got a hole at 3.
You have to do the union thing.
Yeah, so it's negative infinity to 3. Kimberly, is that what you were doing by? So negative infinity, and you go all the way to 3, but you're going to use a parenthesis because parenthesis means it does not include the 3. In union with, and then start back up. So you're going all the way to 3, but stopping at 3 and not including 3, and then you start back up, not including 3, and then going on and on for infinity. So that means all real numbers except for 3. Okay? Let's look at one that you have some exclusions because it would make the x would make it an imaginary number. So for example, let's just say I had, now is there any exclusions here? Is there any x's, any real numbers that I can put in here? When I plug in a real number, I'm going to get out a real number, right? I'm not dividing by 0, nothing's going to give me an imaginary number. If I plug in a real, you could plug in imaginary numbers, but we're only picking from the real number system. Any real number I put in here is going to give me another. So what would the domain be on this? All real numbers, negative infinity to positive infinity. Okay, let's say I had something like this. Is there any numbers I'm going to plug in there that's going to make it that when you work it out, you're going to get not a real number, or you're going to get an imaginary number? Negative 3 I think would be okay because negative 3 plus 3 is 0, and you can take the square root of 0. You just can't take the square root of negative numbers.
Anything down?
Negative 4. Well, how about a negative 3.1? Then you get a negative 0.1.
Just anything less than...
Yeah. So in other words, whatever this inside, whatever I plug in for x, what does it always have to end up to be? Greater than or equal to 0. So I can pick any number that when I plug it in, my answer is, that's basically saying positive. So solve for x, and x, I can pick any x greater than or equal to negative 3. So pick a number greater than negative 3, negative 3.5. I mean, not negative 3.5, that's smaller. Negative 2.5 is smaller than negative 3. Negative 3.5 is smaller. So greater than. So negative 2.5 plus 3 would be a half, and you can take the square root of a half. Okay, does that make sense? What about this one? Oh, how would you write that in interval notation? What x's can you pick? What's a
Negative 3.
negative 3 is the first one you can get.
To infinity.
Yeah, and on to infinity. What about this? Can you have 0 in the numerator? Yeah, 0 divided by anything is 0. So I don't have to worry about the numerators, just what makes the denominator 0 and if there's any x's that would make imaginary numbers. So what's different between this one and that one? Yeah, it can't equal -3 because -3 would make it 0 and you can't have 0 on the bottom. So instead of saying what's inside of here could be greater than or equal to 0, all you can say is greater than 0. So here then you'd have x has to be greater than a -3. So the difference would be, you just wouldn't use a bracket that's in the denominator. Okay, now let's do one more. See if you can figure this one out. Maybe extra credit for whoever gets this one first. So I just got 2 more examples and then we're done. Okay, so here we go. H of x equals the square root of x minus 2 plus the square root of x plus 3. So see who can get that. First one that gets it, just raise your hand and tell me what the domain is. What is the domain of that? And that whole thing is the function. This whole thing is the function. Okay? So you have 2 radicals you have to worry about. So you can't pick anything that will make either one of those an imaginary number. Anybody got what would cause this? What's the domain for just this one by itself? X minus 2 has to be what? Greater than or equal to 0, so x has to be greater than or equal to 2. Okay, so for this one I can pick any x bigger than or equal to 2. What about this one?
-3.
Yeah, x plus 3 is greater than or equal to 0. X has to be greater than or equal to -3. So for this one, I can pick x's greater than or equal to 2. For this one, I can pick x's greater than or equal to -3. The problem is, if I pick something in this area, it will make this imaginary number. So let's say I picked 0. 0 works here, right? But it doesn't work there, because 0 minus 2 is a -2. You can't take the square root of -2. You're going to have an imaginary number. So you have to do their intersection, what they have in common. So it's going to be the intersection of those two. And what do they have in common? Just that part right there. So your domain for this would just be from, and you can include the 2, right? Because it's not in a denominator. So just 2 to infinity. Even though there's numbers in here that works for this one, if it doesn't work for both, you can't include it. Okay, one more. What about this? Okay, this one, how many extra credit points? Keep track of them. 2 extra credit points on the test coming up for the first person that raises their hand and gives me the correct answer to that. What x's, so my answer is all real numbers except for anything that would make it undefined. So you can't divide by 0. Okay, she says 2 and -2. Plug into 2, what's 2 squared? 4, what's 4 plus 4? 8. How about -2? -2 squared is 4, 4 plus 4 is 8. That works.
Trick questions, all real numbers.
Good, you get the point. Trick question, all real numbers. This is not, now if I said something like this, this one has some restrictions, because this that's a difference of perfect squares, right? -2 and 2. This has a plus. Whatever I put in here is going to be positive, and a positive, because if I put a negative squared, a positive plus a positive will always give me a positive number. There's nothing, I have to get a -4 here to make it 0, and there's no way I can get a -4. This is the sum of squares, and you can't factor that. The difference of squares work because you have a positive times a negative to get a negative. Here I need a positive times a positive or a negative times a negative to get that. Your answers and numbers cancel. Very good. Okay, we good with domain? So what would you write for the domain here? -infinity to use 2 positive. If you had this instead, what would you have to be? X cannot equal 2, or how would you write that in interval notation? So you have a hole at what? 2 and negative 2. So, and this is one that's kind of on your homework. So how would you write that in your implementation?
Negative 2.
Negative infinity to negative 2 with parentheses. Union with?
2 to
No, because you got a hole right there. So then in union with negative 2 to 2, and then what would you do? You got to jump, basically you're jumping up right here on that spot. So union from
2 to
2 to
infinity.
infinity. What that does right there is it says all real numbers except for negative 2 and 2. So you guys okay for all these? Okay. Go finish yesterday's and today's.